Now in this lesson we're doing integration by substitution. Examples. We need to find the integral of 4x times the square root of x squared plus 3, and we're using the substitution u equals x squared plus 3. The solution then, let's just write down the integral first, and then a good technique is to let I equal that. Alright, later on it will save us a little bit of writing. Now we're using the substitution, so we're letting u equal x squared plus 3. And the first thing we do is to find du dx. So du dx is simply equal to 2x for that expression. And next step, try to get dx as the subject. And to do that, we just simply replace it with the 2x. Okay, basically swap it around. End up getting that dx equals du over 2x. So therefore, the integral equals, okay, and that was the reason we wrote let I equal that. So we've got that integral. Let's write down the x squared plus 3 with the square root is going to be replaced with the u. So in doing that, we get 4x times the square root of u, and the dx we replace with du over 2x. Now at this point, we basically want to get rid of any x's, and you'll see that those two x's, one on the top, one on the bottom, will cancel each other out. So we've got it equals 2. Now we've got the 4 and we're dividing by 2. Let's simplify that. It's simply 2. And then we've got root u du. Excellent. That 2 now we can just put down at the front. The square root of u, of course, we can write as u to the power of 1/2. So at this stage we haven't done any integration. We've just rewritten it. But now we'll do the integration step. So let's just write down the 2 firstly. The integral of u to the half, well, we add 1. So we get u to the 3 on 2. And instead of dividing by 3 on 2, we'll write the 2/3 in the front, okay? Remembering over 3 on 2 is the same as multiplying by 2/3. And we write plus c, don't forget the constant of integration. So 2 times 2/3, we can write that as 4/3. Now u to the power of 3 on 2, well, don't forget what u was, x squared plus 3. So let's just bring the x squared plus 3 back into play, plus c on the end. Now, at this point, that's okay. That could be a final answer, but good technique is to answer it in terms of the original question, okay? The original question had the square root, so that's what we're going to try to bring in. So let's do that. The 4/3, let's write that in. X squared plus 3 to the 3 on 2, well, that half suggests it's the square root. So let's write the square root, and then it's to the power of 3. So it'll be x squared plus 3 to the power of 3. Plus c on the end. Terrific. Next one, find the integral of 1 over x log x dx using the substitution u equal log x. The solution then, let's write down the integral again. Let's call that I. And we're letting u equal log x. So first step, du dx equals, and the derivative of log x, of course, is 1 on x. Now we're trying to get that dx by itself, making it the subject. We can do a cross multiplication here because we've got one fraction equal to another. So dx times 1 is equal to dx. Then we've got x times du, so we write that as x du. So therefore the integral equals, now the 1 over x log x, we're going to replace that log x with u. So it'll be 1 over x times u. And the dx we replace with x du. Alright, next step there, we want to get rid of any mention of x. So looking at those two x's there, one on the top, one on the bottom, they will cancel each other out. So therefore we have it equal to the integral of 1 on u du. Okay, so the whole integral is in terms of u now. Now of course, integrating 1 on u, we get log of u plus c. And final step, log of u, well, that u was in fact log x. So the final answer, it equals the log of log x plus c. And final example, find the integral of x over the square root of x squared plus 2. And we're using the substitution this time of u equals x squared plus 2. So the solution then, write down the integral, let I equal that. That's our substitution, so let u equal x squared plus 2. And looking at that equation, we're finding du dx, which in this case would equal 2x. Now need to get dx by itself, so we'll swap that with the 2x. So we get the dx equals du over 2x. So therefore the integral equals. Now this is what we've got at the moment, but we're replacing that x squared plus 2, the square root of it, with u. So we're going to get x over the square root of u, and the dx gets replaced with du over 2x. So looking at that, those x's cancel each other out. And let's simplify that. That 2 is effectively on the bottom, so that's a half. So let's put that out the front, the 1/2. And really, even though we don't have a number on top, we know there's 1. So we end up getting 1 over the square root of u du. So we can rewrite that, and all we've done there, 1 over square root of u, we've rewritten as u to the minus a half. Okay, of course we've got to write it in index form. Okay, now it's time to integrate. So let's write the half down. U to the minus a half, the integral, let's add 1. So we'd get u to the half. And if it's over a half, we're dividing by a half, it's the same as timesing by 2. So put that at the front, plus c on the end. Okay, the half times 2, well that's 1. We can just forget about that. The u to the half, realizing that u was x squared plus 2. So we get x squared plus 2 to the half plus c. And final step again, let's write it in terms of the original question. So we're going to write that as the square root of x squared plus 2 plus c. Excellent. Well, that concludes the lesson. Good luck with your questions.